Okay guys, hello. In this tutorial I want to talk you through again like loading network data. In particular, throughout the next few tutorials we'll be working with the London Youth Gang network. That's a data set that my friend and colleague James Densley collected in London. It's about a youth gang in London, 54 individuals representing the nodes and connections between these nodes, representing whether or not these individuals had co-offended with each other, whether they committed a crime with each other. So that's the data set that I want to work through, and in the first tutorial I'm just going to revisit about how to load that data set. So as I said, it's this youth gang data, and when we look at the raw data, you have that in the files as well. It's the actual network data is stored in this file lgang matrix.csv. It's a CSV file, comma separated value file, and you see here now lots of numbers in it. So what does that stand for? So we have like here ID, and then we have 1, 2, 3, 4, 5, 6, and so on, which corresponds to the individuals in that data set. So we have 54 individuals. We have 55 rows, right? Because the first row is sort of the header of this whole thing. So and then we have 54 lines corresponding to the lines in our adjacency matrix. In the same way, you see you have like 1, 2, 3, 4. These are the same individuals that we had over here in the rows, in the columns as well. So each column also stands for the 54 individuals. So when you go to the right, you see we actually have 55 individual rows with numbers going up to 54, and the first row being again like the ID number here and here. So that's the data, that's the adjacency raw data that we want to work with. Let me show you the other data that we have, which is the lgang attributes data. So this is now information about those 54 individuals. So again, the data is stored in a very straightforward way as a CSV file, and where the rows correspond to individuals. They have an ID number. So now I can know, for example, like individual number 40 is the same in this file as in the other file, with the network data. So we have 54 rows in here, with the first one again being the header. And then we have all sorts of attributes in there, like when they were born, what their current age was at the time, where they were born, where they lived, how many arrests they got, how many convictions they got, whether they were in prison, and so on. We asked some about their perceived ranking as well, but what we will be working with mostly is this information, where they were born, and with this information, whether they were in prison, yes or no. So that's the raw data. Now we need to get that data into R somehow. So how do we do it? So I'm kind of running through this revised syntax file. First thing, I don't know, you want to do is load in your statnet package so that all the network abilities are there. Now we need to set the working directory to the folder where we actually have that data. You can do this manually. I do this manually now. Now I go to teaching as I have a folder on my computer where I have this stuff saved. You might have that in a different folder. You have all the files on Brightspace where I put it all together in a zip file that you can unpack and put somewhere on your computer. But if I would go into that, in that folder we have, I don't know, you don't see it, but in that folder you have like these two CSV files. So I set the working directory, and now by default so I don't know, this is a command that you would have to adapt, right? But now I kind of set it here, and you see down here in the console, this is the command that was fired out. This might be a different command for you because you have it saved somewhere else on your computer. But now, whatever you do, just looks into that working directory to begin with. So list file, this now lists the files in this working directory. You see here they are. There's our lgang matrix file, and here's our lgang attributes CSV file. So we have them there. So now R knows where to find these files. Okay. So the next thing, how do we load files? There's a command called read CSV. It's in the base package of R. What this thing would do, it would kind of look up the file lgang matrix.csv. And where does it look it up? Well, in the working directory. So notice you could also do some other things. You could do, I don't know, some other folder and so on, and then it would look into that folder, right? That's totally doable. But it makes sense to set the working directory first, and then kind of reduce these directories in here as much as can. You might save things differently on a different computer, you move it elsewhere, and then you would have to change all these entries, while otherwise you only have to change setting the working directory and everything else runs just nice. So this kind of reads that thing. So we would run that command. That actually creates a data frame. You see now it loaded something. Yeah, I didn't save it anywhere, but believe me, it's a data frame. Let me do this. So I kind of assign it to a variable. Now I call it df. Now whatever that read CSV command does, it saves it in df. And now I can show you that it actually is a data frame. There we go. So a data frame. You could view that data frame. There's the data. There we go. Okay. What we actually need at the end of the day, we want to have this as a matrix object, yeah, the adjacency matrix. So let's just go ahead and let's turn that data frame into a matrix. And these kind of things in R are handled with these commands as something. Yeah. So there's a command as matrix, and you could look up what that one does as matrix. It says it coerces something into a matrix. As matrix attempts to turn its argument into a matrix. So it finds a data frame, and now with the data frame, there's a command safe somewhere that how to turn that into a matrix, and that is being invoked in here. So this command here generates a matrix, and then it saves it into something that I call lg.mat. Yeah. Now, when you look up ls, what I have all sorts of stuff in there. You don't really want to care about that, remove ls list. Okay, now I removed everything. Let me load it again, because I want to show you that now all we have in there is this LG mat. Yeah, and believe me, it is a matrix. Yeah. So we could now display that thing. There we go. But let's check the dimensions of that thing. Yeah. With dim LGMAT, you see it has 54 rows. That's the first number, but it has 55 columns. Why is that? Well, when we go back into the original data file, here it is. You know, remember, it kind of just loaded everything. And read CSV doesn't know that the first column is supposed to be the one that gives the IDs of those nodes in the network. It doesn't know it. For that command, it's just a data set. It's just, so it loads that column as it does all other columns. Yeah? So now what we need to do, we need to get rid of the first column in this matrix. How do we do that? Well, we can subset. Like R is really powerful with subsetting stuff. When you look into that, you subset it with the brackets. You know? And by subsetting something, let's say this would give me the first row, right? Or this would give me the first to the 10th row. Yeah? Or this would give me the first to the 54th row, right? And well, since there only are 54 rows, just leaving it all like that, just having nothing and then comma, does exactly that. So that gives you all the rows. But we want to limit the columns, right? Because we have 55 columns, but we don't want to have the first one. So let's just take the second up to the 55th column. And by the way, you know, this is really just nothing else than a sequence command. You know, it's like same thing. There we go. There we go. So it's the same thing as sequence 1 to or 2 to 55 of steps in one. So that's the same thing, right? And that shows you how you can put these commands inside other commands. So it essentially generates a sequence. Would have been the same as writing really like C2, 3, 4, and so on. But that's ridiculous. Nobody wants to do that. So we do like that. Okay. And now let's check the dimensions of this thing. Dim LGMAT. Now it has 54 rows and 54 columns, which is exactly what we want. Let's look a little into that matrix. So what is in there? So I can use the table command to give me an idea about what are the values that it finds in this matrix. And you see most of the values are zeros, there are some 1s, 2s, 3s, and 4s. So what do these values stand for? Well, that's how we collected the data, and we collected the data in a way that 0 means these guys, they just don't know each other. 1 means 2 individuals, they know each other, they hang out with each other, based on CCTV camera footage. 2 means they committed a crime with each other. 3 means they committed a serious crime with each other. And 4 means they committed a serious crime with each other, but they're also blood related. So now to simplify things, I'm going to turn this in a dichotomous in a binary network where we only want to have 0 meaning they didn't co-offend with each other and 1 meaning they were co-offended with each other. Right? So all we need to do is we need to group the 0 and 1 together and turn that into zeros, and we need to group the 2, 3, and 4 together and turn that into ones. How can we do that? Well, there are different ways how you can do that. You can different recode commands. One way that I'm using here is I'm taking the values ones and I'm turning that into zeros. Yeah? So this becomes 0. And I'm taking everything that is 2 and greater than 2 and turn that into ones. So how do I do that? Well, these are the two lines that do that. These are the two lines. When you look a little closer and want to understand what these commands do, here again we have like a subset thing, but inside that subsetting thing we have like this basically a Boolean operator. Are these the same? This gives you a true or false value back. And because on the left hand side we have a matrix, it gives you a matrix of trues and false back. So when I run this, it gives you a matrix of 54 times 54, which is the sizes of LGMAT, right? And for each entry, it tells you whether the entry in LGMAT is 1, yes or no. So you get trues and falses and so on. So I only get the ones that have true. So for example, this guy has like the first individual to the 64th individual is a true, meaning that is a 1 value in LGMAT. We want to set that to 0, and that's then what this command here does. So we subset, so that's kind of like embedding this thing within itself. So we kind of first use that to get true and false matrix, and then we subset the matrix, and only where there's a true value in there, it changes the value in LGMAT to 0. And this does something similar. This here gives me now a matrix again, like 54 times 54, but where the value true, here's a true value, for example, means that in the original LGMAT matrix, the value that you find there is 2, 3, or 4. Yeah, so they co-offended with each other. And that's the one that we want to set to 1. Okay. And now let's look into that a little bit. Not LGNet, LGMAT. So when I run this line, now you see, now we only have zeros and ones. Okay. So now we have our matrix. Great. We're almost there to get our network done. Remember, how do we make a network object? Well, there's this command called network. It's very straightforward. Yeah. Let's look at the help file for a second. It kind of constructs courses or tests and print a network object, so it does all sorts of things, but it kind of creates a network object, and one way to do it, it's the simplest one, is you just give it as an argument as X a matrix. There you go. A matrix giving the network structure and adjacency form. There you go. So now we have our adjacency matrix, LGMAT, 54 times 54, corresponding to our individuals. Yeah. And it only has now the value 0 and 1, where 0 means they did not co-offend with each other, and 1 means they co-offended with each other. We use that as an argument, and then we kind of also specify directed, set that to false. We do that because by default, network generates a directed network. And in this case, it's an undirected network, so they just co-offended with each other. It's not that one can co-offend with A can co-offend with B, but B did not co-offend with A. That doesn't make sense in this case. So it's just naturally an undirected network. And that's what this command does. So network with a matrix in it, directed set to false. And now we have something new. When you look at what we have now, we have LGMAT, but now we have also LGNet. And LGNet is now a network object. Network object, there you see 54 individuals. It has 133 ties in total. It's not directed, meaning it's undirected. And that's the network that we want to work with. Let's plot this for a second. There we go. And that's the network of co-offending in this London Youth Gang that you've seen me working, and that we actually published a couple of papers with. Okay, now let's take one step further. This is now really just the network, but we want to give those nodes attributes. Yeah? We want to say either who of those individuals went to prison, or where were they born. Yeah? So we want to bring in that information that we have saved in this attribute file. Here it is, right? So that's the information. So we need to load that data, and put it somewhere. So again, like read CSV loads the data, it kind of looks it up in the working directory file. We set that, you can find that file there. And when I run that command, now it generates a new thing. And when you look a little closer, it's actually a data frame which hosts all the information. You can view a data frame with view, sort of like a nice way of getting access to data. There you see, this is really just now the data. There you go, great. So we have the data, but now we need to attach that somehow to the network, because right now that just lives as a separate data frame object somewhere. So we need to take that data and attach it to the network. And let's look at the birthplace variable that is being generated. It kind of, with read CSV, it kind of takes the first row and it kind of interprets it as names for those columns. So it generated a column in this new data frame called birthplace, and it has these values in it. And when we look into that, let me just take that out for a second and look into it. Now you see, okay, now I have all these values where they were born, 54 entries. But there's something else to it. You might not see it, but you can see it because there's something written here, levels at the bottom. So that means like this information is saved as a factor. It's not saved as a string. It's saved as a factor, and a factor is internally something else. That's basically what happens here is that R doesn't save that as West Africa, UK, and so on, but it saves it internally as 1, 2, 3, and 4, right? And then it has a dictionary where it looks these up, and this is sort of indicated by these levels. So internally it saves, wherever you find a Caribbean, it saves it as a 1, right? Or wherever it finds East African, it saves it as a 2, right? So that's not what we want at the moment. You actually, to be honest, probably one could do it, but you could just easily get the true value. Forget about this factor thing. That's just how the read CSV command runs. Take that out, and if we really want to have the string, let's say, then you use as character and take what you find in there. So you see now with running as character, LG attribute $birthplace. So take the birthplace column in LG attribute, which is data frame. Just return that as a character. And now you see it in quotation marks. So now they are really true characters. So now we want to take those strings and attach them to the network. And we want to give nodes an attribute that is called ethnicity. And so there we go. And that's sort of like a straightforward way to do it. Now you see here is a certain kind of notation, that kind of how it runs in the StatNet package. You can take the name of a network and then %, v, %, and then something in quotation marks. That means look at a vertex attribute and look at a vertex attribute called ethnicity. There is none yet, so it creates one. Right? So in the network, it creates for each vertex the attribute ethnicity, and take the information that you find in here, in this data frame, and turn that into a character. So if you run that, that now attached the information about birthplace to the network. And now we have in our network, when we look it up, and you see there's our network, 54 individuals, 133 edges. Now we have like a vertex attribute called ethnicity here. So now each node has an attribute there. So that's one way of doing that. There's another way of doing that, and like oftentimes there are so many different ways of doing exactly the same thing, and that's this one. It's like using a command called set.vertex.attribute, and then it takes the network, and then it takes whatever you want to call it, an attribute, and then take the values of it. This command does exactly the same thing. So now we have our network with this ethnicity node level attribute. Let's generate one more node level attribute, and then we're almost done for this first session. So I do the same thing and take the information that I find in the prison variable. There we go. There I don't have to transfer it, turn it into an as character, because it is a number to begin with. And now we have the network here. Now we have like 2 vertex level attributes plus the vertex name. So that's always by default being generated anyway, right? And now let's go and let's plot the network. We've already seen the first plot. There we go. But now I'm going to plot, and I'm going to change as the color of the nodes. I'm going to use the information stored in ethnicity. So now that's a nice thing. I don't have to use some other information elsewhere. I can just use quotation marks, and it looks up the node level attribute. And now I see different colors of it. Yeah, you don't really see it. Let's make it a little bigger. Vertex cx equals 3. Let's do that. That just increases the size of all nodes. Yeah. So now you see the colors a little clearer. So now I just assigned a value to each of those different birthplaces where those guys come from. Let's do the same thing for the prison variable, vertex cx. And I'm just doing that so that you can see it better. So now we have an animation. Some integers were in prison, others were not in prison. Okay, so that's it for the first tutorial. Yeah, and another one to follow. But this is really just to catch up on how to load that data set. We're going to work with that data set a little more later.